Today we're breaking down breaker sizing and how to actually find the right breaker on a real job site. No guessing. If you've ever flipped breakers back and forth, trying to figure out what feeds what, this is for you. So again, welcome back to the channel, and I would like to thank you guys all for tuning in to the live stream tonight. So again, for all those who are tuned in, we're going to be going over a couple breaker issues here that we see on the job site and so on. So I'm going to start off with give me a second here while you guys wait there. Okay, so let's get started here. So again, breakers protect the conductor, not devices. 15 amps versus 20 amp. I'm just going to pin a comment here before we get going here. Okay, so let's get started. So breakers protect the conductor, not devices. 15 amp versus 20 amps circuit. 80% rule continuous is out of the code book. Most people get this wrong. Their size based on device and not the wire. So I'm going to pull up the actual rule for that right now. I'm going to share the screen. And for all those who are tuned in to the live stream, don't forget to like up the live as you enter. So I'm going to share the screen here for a second here. And this is rule 8104. And this is part of the actual rule that we're going to get into. So let's just pull up on the screen. And again, for all those who are tuned in to the live stream, I'm Fabian from Fabian Electrical Services Inc. As you can see at the bottom of the page, 8-104, that's basically, let's see if you guys are seeing that. 1 second here. Let me go back to sharing the screen one more time. Let's see what's going on here. Okay. Pick that, share the screen. Okay, let me see if that's going to pop up on the screen. So again, for all those who are tuned in to the live stream, as you guys enter, don't forget to like up the live. And tonight's live stream is going to be a pretty long one here. Stick around and you'll get to see me performing some work. So again, 8-104, maximum circuit loading. It goes on to say, see Appendix B, but I'm just going to read this out here. Again, don't forget to like up the live stream as you guys enter. Very important. Please and thank you. So see Appendix B, 8-104, maximum circuit loading. 1. The ampere rating of a consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device protecting the circuit or the ampacity of the conductor, whichever is less. Also goes on to say, 2. The calculated load in the circuit shall not exceed the ampere rating of the circuit. So I'm going to go to the other page. Again, for all those who are tuned into the live stream, don't forget to like up the live stream. I'm Fabian from Fabian Electrical Services, Inc. It also goes on to say, number 3 of the Canadian Electrical Code Book, for all those who are tuned into the live stream. I'm working off of the 2024 Ontario Electrical Code Book. The calculated load is a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that in normal operation it will not persist for a total of more than 1 hour. A total of more than 1 hour in any 2-hour period if the load does not exceed 225 amps, or a total of more than 3 hours in any 6-hour period if the load exceeds 225 amps. A load of a cyclic or intermittent nature shall be classified as continuous unless it meets the requirements of Sub-Rule 3. Where a fuse switch or circuit breaker is marked for continuous operation at 100% of the ampere rating of its overcurrent devices, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker. And also goes on to say, A, except as required by item B. Item B shall not exceed 100% of the ampacity of conductors selected in accordance with section 4, or B shall not exceed 85% of the ampacity of single conductors selected in accordance with section 4. Where a fuse switch or circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent device, the 80% of the ampere rating of its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker. And A, except as required by item B, shall not exceed 80% of the ampacity of conductors selected in accordance with the section 4, or B, shall not exceed 70% of the ampacity of single conductors selected in accordance with section 4. So again, for all those who are tuned into the live stream, welcome to the live. Again, don't forget to like up the live stream. Just tap the like button, helps with the channel. You can also join the channel, also stay up to date to my weekly live streams and also my videos and shorts. The continuous load as determined from the calculated load connected to a cable bus shall not exceed the value specified in Sub-Rule 5 or 6. So again, this is section 8-104 of the code book. And again, you're tuned in to Fabian Electrical Services, Inc. And that right there, what we went through, I'm going to put it on the screen for you guys. Um, so again, that was breaker sizing. So right now I'm going to go into segment two, common mistakes that are made on the job site that I see constantly. It doesn't matter which job, if it's residential or commercial. Oversizing breakers. Again, oversizing breakers is dangerous. And again, I'm going to show you an example here of what I'm talking about. So right here, I have two different types of breakers. Uh, One of them is a 20 amp two pole breaker. So again, this is basically, let's see here. Sorry about that. This is a 20 amp two pole breaker. This is a 15 amp single pole breaker. So oversizing, what oversizing is basically if, or undersizing we can say, is if you take a 14 gauge wire and you place it on this breaker here. This is a 20 amp breaker. I'm going to show you it in single. That's a 20 amp two pole. This, I don't think I have a single 20 amp here, but this is a 20 amp two pole for all those who are tuned into the live stream. So this means you cannot feed this with a 14 2 wire. Okay. What happens when you undersize the breaker? Again, the breaker protects the wire itself, the circuit. It doesn't protect the devices, and that's the problem with a lot of people. Um, a lot of electricians and so on, they get it confused. Even homeowners and so on, apprentices also. You do not undersize the breaker. Uh, you do not undersize it. You always go with what you have. So if this is a 20 amp breaker, 20 amp two pole, you have to use a 12 2 wire on here and so on. You cannot go down. So again, oversizing breaker, when it comes to oversizing breakers, you can oversize your wire, but when it comes to the actual breaker and the current that it's going to be using, you have to make sure that you size your actual circuit accordingly. So again, the breakers, your breaker only protects the circuit, it protects the wire, it does not protect your devices. So let's say you have your let's say your stove, you have your fridge, and so on. Your breakers do not protect them. They only protect the wire. So don't get that confused. And again, wrong sizes. Using the wrong size when it comes to sizing your breakers. Um, Again, undersizing your cable is again dangerous. Always try to oversize. That's the difference between up upsizing your wire and downgrading your wire. When it comes to doing your installation, you might want to have a 20 amp receptacle instead of a 15 amp receptacle. So if you pull 14 2 wire, Romex, BX, whatever it may be, you now you have to make sure that you oversize your cable to make sure that you're going to have the proper circuit that you need. Again, guessing circuits. A lot of us we guess circuits also instead of seeing what it's drawing and so on. Again, that's how you size your wire, you size your circuit, going to the code book and looking for the actual rule that's there. It is inside of the code book. You will find it there. When you're sizing your circuit, always make sure to size it from the code book. So again, if you're using 14 2 wire, it goes on a 15 amp breaker. If you're using a 12 2 wire, it goes on a 20 amp breaker. If you're using a 10 3 wire, it goes on a 30 amp 2-pole. If you are using an 8-3, it goes on a 40 amp 2-pole breaker. So that's the rule out of the OESC 2024 code book. Also, whoever are following, I'm not sure if you're tuned in from the States or Canada. You can type in the comment section where you're tuned in from. Also, don't forget to like up the live stream as you guys enter. Very important. So anyone here open a panel and nothing is labeled properly? So again, you can type in the comment section. Let me know if anyone has opened a panel. I'm going to go on to segment 3 right now for all those who are tuned in to the live stream. Again, don't forget to like up the live stream as you enter. Very important. So on a real job, you don't have time to flip breakers all day. That's a big problem. Time wasted. There's so much confusion going on when it comes to job site awareness and so on. When you get on a job, you don't really have time to waste. Time is precious, so you want to make sure that the job is done accordingly. You want to make sure that you have the proper tools also for the job. What happens when you have the proper tools for the job? You end up going to your job and spending less time than you would have spent on the actual job, which means that you can turn around and turn a 1-hour job into basically 15 minutes. And I know a lot of you are probably saying, where am I getting that from? I do it every day, and also I've literally experienced it in the last week and a half or so. With the proper tools, it can help you. It can help you so fast. Proper tools, proper testers, and so on. So right now we're going to go into segment 4 for all those who are tuned in to the live stream tonight. Again, don't forget to like up the live stream. Very important. Also, don't forget to you can also join the channel for all those who are tuned in. And we're going to be getting into segment 4. Again, this is going to be the Kiwi demo plug-in tester. I'm going to run a couple shorts here to show you guys how I go about doing the testing and how it saves me a lot of time. So again, for all those who are tuned in, I'm going to run a short clip here, a short clip, and then I'm going to go over what I'm playing here. So let's go here. Also, don't forget to like up the live stream. So again, this clip is going to be about breaker troubleshooting. It's going to be troubleshooting here. I'm going to run a couple clips here. So let's go here. Most electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule. Anything running over 3 hours, that's a continuous load. If you don't size this properly, you're setting yourself up for failure. So basically what we have here is a Kiwi demo plug-in tester. This is a Kiwi brand tester for those who are tuned in to the live stream. I kind of was muted there, so I'm going to replay that little short there that I played. What it is most electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule.
Anything running over 3 hours, that's a continuous load. If you don't size this properly, you're setting yourself up for failure.
Do your job faster. It does work. I've been working it on the job. Again, I'm going to explain to you guys how I use it. Also, I'm going to run another clip here. So again, this is the breaker.
Ever spent 10 minutes trying to find the right breaker? Electricians use a breaker finder like this. Scan the panel and it finds the circuit in seconds. KAIWEETS sent me this breaker finder to test.
So again, this scanner here gets the job done. This is what I mean by going to a job site and pretty much cutting an hour's job into basically 15 minutes. This breaker, this plug-in transmitter breaker tester works. It's a Kiwi brand. I'm also going to show you it on the live tonight, so stick around. I'll show you how it works. So this will be a live demo and so on. So again, don't forget to like up the live stream. So I'm going to run another clip here of the Kiwi tester, and then I'm going to show you guys.
Stop guessing breakers. Most electricians are flipping breakers. Instead, use a breaker finder. Scan the panel. Find the breaker in seconds. This saves time on every job.
Breaker tester here. You see, again, this breaker tester is what I use on the job. Cuts the job down into 15 to 20 minutes for me. Very useful. Again, Gloom Platoon, thank you for joining the live stream. Again, don't forget to tap on the live stream, give it a like as you guys come in. So I'm going to show you guys the actual Kiwi tester that I use on the job for all those who are tuned in. So this is the brand here. Let me enlarge the screen so you guys can see better. Hopefully, let me enlarge this here. So again, this is the Kiwi brand here that I've been using, and I'm going to explain to you guys how I basically use it. Again, thank you guys all for tuning into the live stream. Again, with the Kiwi tester, you have the actual scanner, and you have the actual transmitter. So it comes with a couple parts here. Again, this is the transmitter. This is what actually you're going to plug into the actual socket. You just saw it there on the live stream on the video that I just played. Again, this is the transmitter that is on. This is what I basically use on the job site. You have your test button right here, and you also have your on button. And what happens is when you turn this tester on, you're going to see that you're going to have voltage here. This is the screen where you're going to have your voltage and so on. You're also going to have open. It also shows open. It also tells you if it's an open line, if your line is open, if your neutral is open. So it tells you everything here. Again, to use this properly, your panel cover has to be off, obviously with the proper safety gear on, and you also have the scanner. So this is the scanner, and this is what you basically how this basically works. You have the transmitter here, you have the scanner. This goes into the outlet. Once you press the on, you're going to see a signal going around here. it's like a Wi-Fi signal. You're going to pretty much scan this down your panel onto your wires. Once this turns red, that's basically going to be telling you that that's your cable that you need. So this is how I go about using this and saving time on the job site. Again, I've got more than one, but I've been using this one. What it also has is a actual lead for your actual wires. If the wires for some reason is hot, if the wires is stripped, there's no cable, it's not plugged into receptacles or so on. These are the leads. You simply plug these onto the leads, and you also going to plug this into here. Once you plug this into here, you turn this on, and here, voila, you have this again. You can scan this with just the ends of the wire. So a great tool. And you don't only have that, you have what you have here is a light bulb, screw-in light bulb. You screw this into the light bulb. For all those who have a light bulb, you can screw that into the light bulb. And again, trying to trace your circuits at the panel, it's very confusing sometimes when you do have a panel and there is so much stuff going on at the panel. You want to make sure that you get the job done fast. So you can basically screw this socket into the actual light bulb itself, and you can take the scanner, run it down the actual panel cover or the wires itself, and this is going to light up, and you're going to find your circuits. So again, that is the Kiwi circuit breaker tester that helps me save a lot of time on the job. Again, imagine you're going to a job and you're going to spend 2 hours, but you have this tool here that you've finally came across. And again, this was again, you finally came across, and you are using it correctly in order to get your job done efficiently and fast. That's what you call saving money, saving time on the job. So again, this also, again, scanning. This also identifies the circuit at the panel. It tells you the correct circuit that you're looking for. So again, for those who are tuned in to the live stream tonight, don't forget to like up the live stream. Please and thank you. Very important. Again, for all those who are tuned in, you can join the channel also. So I just showed the demo of the actual plugin tester itself, and I'm going to show you. So again, I have 2 of them. One is I have a Klein also. So I'm going to show you what the Klein looks like. The problem with the Klein is that the Klein is not digital. It's a simple, straightforward one here. These are the difference between this and the Kiwi brand. This is the Klein type, and this here is the transmitter itself. Again, sorry, the scanner itself. This is the receiver, and it just has the buttons here. You see, as it turns on, it's going to light up. Again, red is for bad. The 2 oranges is going to be basically telling you that your circuit is correct. Again, this is just a simple plug-in scanner. That's the Klein, but with the Kiwi brand also, for those who are, this is the actual correct one. if it is if the circuit is correct, it's going to light up green here. If the circuit is bad, it's going to show you red here. So that is basically it for the tool part for the section here, segment, the Kiwi plugin transmitter here. So again, this removes all guesswork. This is a real job efficiency, not theory. You save time on every single job with this tool. So again, we're going to so I want to go back into the actual breaker, that so again, let's go into segment 5 here for all those who are tuned in. If you are tuned into the live stream and you just tuned in, don't forget to like up the live stream. Please and thank you. Very important. So again, that was the Kiwi demo plugin tester that I just showed. I'm going to go on to segment 5, when to basically use it. So again, you use it when you're troubleshooting and so on. Trying if you go to a job site and you happen to find out that the actual job, the wires are messy at the panel, you want to make sure that you're going to get the job done correctly, accordingly. So you're going to basically use the plugin transmitter tester, breaker finder. You're going to use it on the job to get the job done faster. So I'm going to go back into the code book here for all those who are tuned in to the live stream. We're going to go into 14. That is part of the breaker rule. If you missed the live stream, don't forget to like up the live. So we're going to, this is segment 5, and I'm going to just go into this actual rule for all those who are tuned in. It's part of the actual breaker sizing rule. A lot of us get it mistake. A lot of us get it wrong a lot of times, and we're going to go into this last rule here for the night, and then we're going to have engagement questions for all those who are tuned in to the live stream. So I'm trying to make my way over to the actual rule itself for those who are tuned in. Again, don't forget, you can join the channel. Also, stay up to date to the actual live stream and the videos. Okay, so this is actual 14 100 for all those who are tuned in to the live stream tonight. Thank you guys all for tuning to the live stream. I don't see it up on the screen here, so I'm going to. Okay. So let me switch back my actual screen here. That might be the actual issue here. So I'm going to switch back my screen. Okay, so right now I'm trying to show you guys the screen here, but for some reason, okay, I'm going to remove it and add it again. Okay, so I'm going to stop the screen here and then I'm going to add it back for all those who are tuned in to the live stream here. Don't forget to like up the live as you guys enter. Again, you're tuned into Fabian Electrical Services Inc. And what we're going over tonight is for those who missed the beginning of the live stream. This is 14-100. It should be coming up on the screen. Okay, so this is the part of the rule again, 14-100, overcurrent protection of conductors. It tells you to go to Appendix B. However, I'm not going to go over to Appendix B for all those who are tuned in. So it says each underground conductor shall be protected by an overcurrent device at the point where it receives its supply of current, and at each point where the size of conductors is decreased, except that such protection shall be permitted to be omitted in each of the following cases. So again, for all those who are tuned in, we are in the actual OESC 2024 code book. For all those who are tuned in to the live stream, again, don't forget to tap on the screen to like up the live, please and thank you. So I'm going to go over that rule again. 14-100, overcurrent protection of conductors, tells you to see Appendix B. Each underground conductor shall be protected by an overcurrent device at the point where it receives its supply of current, and at each point when the size of conductor is decreased, except that such protection shall be permitted to be omitted in each of the following cases. Where the overcurrent device is a larger conductor, properly protects the smaller conductor. Where the smaller conductor has an ampacity not less than the combined completed load of the circuit supplied by the smaller conductor and not less than the ampere rating of the switchboard, panel board, or control device supplied by the smaller conductor is not over 3 meters long, does not exceed beyond the switchboard, panel board, or control device that it supplies, and is enclosed in non-ventilated raceways, armored cable, or metal sheeted cable when not part of the wiring in the switchboard, panel board, or other control devices, where the smaller conductor has an ampacity not less than one-third that of the larger conductor from which it is supplied, and is suitable protected from the mechanical damage, is not more than 7.5 meter long, and terminates in a single overcurrent device reading or set at a value not exceeding the ampacity of the conductor. But beyond the single overcurrent device, the conductor shall be permitted to supply any number of overcurrent devices. Where the conductor forms part of the only circuit supply from a power or distribution transformer rating over 750 volts with primary protection in accordance with Rule 26-251, 2, and 3, and the supply and that supplies only that circuit. Terminates at a single overcurrent device with a rating not exceeding the ampacity of the conductor in the circuit, and is protected from mechanical damage, where the smaller conductor is number 14 or larger, is in a control circuit and is located external to the control equipment enclosure, and the rating or setting of the branch circuit overcurrent device is not more than 300% of the ampacity of the control circuit conductor, or the opening of the control circuit would create a hazard. Where the smaller conductor supplies a transformer, and the conductor supplying the primary of the transformer has an ampacity not less than one-third that of the larger conductor. The conductor supplied by the secondary of the transformer has an ampacity not less than the ampacity of the primary conductor multiplied by the ratio of the primary to the secondary voltage. The total length of one primary plus one secondary conductor, the longest if more than one winding, excluding any portion of the primary conductor that is protected at its own ampacity, does not exceed 7.5 meter. So that 7.5 meter, again, that is used on the job site, and you will see it again once I touch further down into the code book. So again, for all those who are tuned in to the live stream, don't forget to like up the live stream as you guys enter. Helps with the channel. You can also subscribe to the channel to stay up to date to my weekly live streams. I go live every Wednesdays, 9 p.m. And I also drop my videos also on Mondays. So again, we're going to continue. The primary and secondary conductors are protected from mechanical damage, and the secondary conductor terminates in a single overcurrent device rated or set at a value not exceeded its ampacity, or where the smaller conductor is supplied by a circuit at not more than 750 volts. A supply from an overhead or underground circuit and is run overhead or underground, except when it enters a building, is installed in accordance with the requirements of Section 6. And we're going to go over to the other page because that's where it's sending you. Again, this is 100. It says terminates in a service equipment in accordance with Section 6, notwithstanding Subrule 1, consumer service conductors shall be permitted to be protected by an overcurrent device at the service equipment. So again, for all those who are tuned in to the live stream, thank you guys all for tuning in to the live stream tonight. Again, don't forget to like up the live as you guys enter, and you're tuned in to Fabian Electrical Services Inc. And tonight's topic is again electricians get this wrong, breaker sizing. Again, we're all human. So again, rule dash 8-104, maximum circuit loading. Continuous loads must be calculated at 125%. Example, a 20 amp breaker times 80% equals 16 amps continuous load. Example, electric heater drawing 16 amps. A 20 amp breaker can safely carry about 16 amps continuously. That's right out of the code again, 8-104. You're going to find that rule, the 80% rule. It is in there. Basically, what the 80% rule is you cannot max your circuit out. You have to have enough left over for the circuit to work accordingly. Again, your breaker protects the wire, it doesn't protect the device. So a lot of us get confused, and we somehow think the breakers is actually there to protect the device, but it's not protecting the device, it's protecting the actual wires itself. Again, I'd like to thank Goon Platoon for joining the live stream today. So for all those who are tuned in, you can follow me on the channel here, and what we are discussing, electricians get this wrong, breaker sizing. Again, breaker sizing is important to the actual circuit itself. So when sizing your breakers, always try to go off of the code book. And we're just going to stroll down here before I actually go into the actual segment that I want to go into. So ground fault protection, it tells you to see Appendix B. However, I'm not going to go to Appendix B. So for those who are tuned in, if you do have your code book out and you want to head over to Appendix B, you can. Appendix B is very important to the code book. This is a rule that is sending you to. You basically go to the back of the book, you open up your back of your code book, you go to the actual rule itself here, 14-102 in Appendix B. You look for that rule, and it's going to give you some more valuable information that you actually need to actually carry out the job, so you can have it done safely and pass your inspection. So Appendix B is very important, but we're not going to go there. I'm going to just read off 14-102. Ground fault protection shall be provided to de-energize all normally underground conductors of a faulted circuit that are downstream from the point or points marked with an asterisk in diagram 3 in the event of a ground fault in those conductors as follow. For circuits of solidly grounded systems rated more than 150 volts to ground, less than 750 volts phase to phase, and 1000 amps or more. And it also tells you B, for circuits of solidly grounded systems rated 150 volts or less to ground and 2000 amps or more, except as permitted by Subrule 8, the maximum setting of the ground fault protection shall be 1200 amps, and the maximum time delay shall be 1 second for ground fault currents equal to or greater than 3000 amps. It also goes on to tell you, again, this is 14-102, Subrule 3A. The ampere rating of the circuit referred to in Subrule 1 shall be considered 2B. So Subrule 1, that basically is, you have to read that subrule also in order to understand what you're doing here. The ampere rating of circuit referred to in Subrule 1 shall be considered 2B. A, the rating of the largest fuse that can be installed in a fusible disconnect device. The highest trip setting for which the actual overcurrent device installed in a circuit breaker is rated or can be adjusted, or the ampacity of the main conductor feeding the device located at points marked with an artistic in item 2 of diagram 3 in the case where no main disconnecting device is provided. Subrule 4, 14-102, A, this protection shall be provided by, goes on to tell you, A, an overcurrent device that incorporate ground fault protection. Also tells you B, a ground fault tripping system consisting of a sensor, relay, and auxiliary tripping mechanism or other means. The sensor referred to in Subrule 4 shall be A, this is Subrule 5, 14-102, A, sensors that vectorial vectorially totalize the currents in all conductors of the circuit, including the grounded circuit conductor where one is provided, but excluding any current flowing in the ground fault returning current path. So I'm going to turn on my screen here while I pull back up the live stream here. Again, I'm going to use my phone here. This is why I have it on the screen, so I don't actually lose what I'm doing here tonight. So again, for all those who are tuned in to the live stream, don't forget to like up the live stream. You are tuned in to Fabian Electrical Services Inc. I'm Fabian, and again, tonight's live stream, Electricians Get This Wrong, Breaker Size Explained, OESC 2024 is what I'm basically working off of. I'm going to pull back up the screen here. So I'm going to share the screen for all those who are tuned in. Again, don't forget to like up the live stream as you guys enter. Very important. So I'm going to go back to where I was. So 14-102. 14-102 is where we are right now. and we are in 5, sub rule 5. Okay, I'm going to read back over the sub rule 5. If you're apprentice, journeyman, licensed electrical contractor, you can drop a comment in the comment section here. So the sensor referred to in sub rule 4 shall be, and it says A, sensors that are vectorially totalize the currents in all conductors of the circuit, including the grounded circuit conductor, where one is provided, but excluding any current flowing in the ground fault return current path. Sensors that sense ground fault current flowing from the fault to the supply end of the system through the ground return path. So again, there you go. My screen has gone again. So I'm going to try to finish this live stream on the actual phone itself. I guess the StreamYard is giving me issues here. So again, this is segment 5. I'm going to go on to the last segment of the live stream. For all those who are tuned in, don't forget to like up the live stream as you enter. Please and thank you. Very important. And I'm going to remove segment 5, when to use it, and we're going to go over to the actual recap of the live stream. I'm supposed to let's see if I missed that there, step by step. 75 when to use it. Okay, so for those who are tuned in, let me pull back the actual. Sorry here. So if you are just tuning in and you missed the beginning of the live stream, you can catch it on the replay when it's available. And I'm going to remove that off there. I'm going to do a recap of the live stream tonight. And then we are going to so again, segment 6 recap tonight. Recap what we have tonight is basically why electricians get it wrong. That is the live stream title tonight. Electricians get this wrong, breaker sizing. So if you missed the beginning of the live stream, you can catch it on the replay. You can catch the so again, I'm going to give you the quick summary here for all those who missed it. So today we're breaking down breaker sizing and how to actually find the right breaker on a real job site. No guessing. Again, if you ever flip breakers back and forth, trying to figure out what feeds what is, this is for you. Again, drop in the chat, are you still flipping breakers or using a tool? And let me add this back to the screen here. And I'm going to pause this here. Okay, so so again, this is basically a recap of the live stream tonight for all those who are tuned in. Again, what we would have discussed, segment 1 would have been breaker basics. Again, breakers protect the conductor, not the device. 15 amp versus 20 amp circuits. So the 80% rule, continuous load. You can find that in the actual code book 8-104, and then also 14-101 is part of the actual rule also. So again, most people get this wrong. The size based on devices and not the wire. This is part of what I would have covered through the live stream tonight. Also, common mistakes that people make: oversizing breakers, wrong wire size, guessing circuits, not labeling panels. Again, when it comes to labeling the panel, you should always try to label your panel. Why? Because I'm going to actually turn off that camera there. So again, when it comes to actual sizing your breakers and labeling your panels is very important to do that. Why? It helps with troubleshooting. Again, when it comes to labeling, you should have all labels on the panel. And again, that was part of the segment tonight. Guessing circuits. A lot of us guess circuits. You walk back and forth and so on. And when you walk back and forth and so on, it takes time to actually get the job done. So you're actually taking more time on the job than using the proper tools. So again, that was part of the segment. And then, I spoke about real jobs. You don't have time to flip breakers. It's a waste of time. So you basically have to have the proper tools to do the job. And that's when I would have introduced the KAIWEETS brand tool here. Again, this is what I use on the job site. It's a actual KT01P. KT01P is what it is. The description is pinned in my comment section for all those who are wondering. You can find it in the comment section. You can also find it at the top of the comment. The top of the chat. It's pinned at the top. You can click that link and you can head over to the actual website and check it out. Also, so that is the actual. This is the transmitter, okay, and basically it's a digital transmitter, KAIWEETS breaker finder. That's what it is. That's the transmitter, and this is the actual scanner. So this is part of what I went through tonight. And again, if you missed the live stream, the opening of the live stream, you can catch it on the replay. So that is actually part of the live stream. So again, I'm going to now go into engagement questions for all those who are tuned in to the live stream. If you want to drop a question, you can drop your question tonight here on the live stream. I'm actually going to try to create, let's create one here. So this is engagement questions, guys, for all those who are tuned in to the live stream. You can engage in the comment question right now. You can also drop your comment in the comment section. And we're going to, I'm going to engage with you guys right now for all those who are tuned in. So this is engagement questions. For all those who are tuned in, if you want to drop a comment in the comment section, tell me where you guys are tuned in from. Again, are you a licensed electrician or licensed journeywoman, apprentice, DIY, or your electrical contractor or so on. Again, would you use something like this or still flip breakers? The question is, would you use a breaker finder or would you still flip breakers? Again, you have to keep in consideration flipping breakers. When you start to flip breakers and so on, you're walking back and forth. Your knees get tired, your legs get tired, your feet get tired. At the end of the job, you're basically dead. You can't walk. After walking back and forth to the stairs, up and down the stairs, sorry, um, to find the circuits instead of using a simple breaker finder. Very easy, gets the job done fast. Um, so again, the question is, would you use something like this or still flip breakers? I know me, I've gone away from actually flipping breakers. I'm going to be using this constantly. Again, or there's multiple ones that I can use. Again, this one here actually has the screen is digital, so it shows me everything. Again, when am I going to use this? I'm going to use this breaker circuit breaker finders are used best for renovations. You're trying to find the circuit. When it comes to renovation, you know that there's going to be a lot of cables not labeled. People are going to move around circuits and so on. It's going to make your job a lot harder to actually find the actual circuit itself. So again, I'm trying to. I should have moved up my chair, but it's okay. I'm not going to worry about it. So, um, renovations, I would use it on a renovation job. I would also use it on troubleshooting. When it comes to troubleshooting, you got to keep in mind that troubleshooting takes a lot of time. And when it comes to troubleshooting, you have to understand that it takes time. Um, I'm going to give you a real life story, which happened actually today, where I was actually installing under cabinet lighting, and you know, again, the wrong circuits or your head is off or so on. You can actually get your wires mixed up and so on. And when that happens, you're going to start to actually have to troubleshoot and so on. So again, troubleshooting is best when you are. So hold on a second here. I'm going to move this. Actually, no. Sorry. I'm going to leave it the way it is. And again, so if you see the actual screen moving, it's because I cannot have the phone on. It's going to echo in the back screen here. So that's why you're going to the other screen. You're going to see my voice going there. Anyways, so let's keep going here. Again, for all those who are tuning, don't forget to tap on the screen, like up the live stream, like up the live stream. So troubleshooting, when it comes to troubleshooting, you have to understand that it takes time. You have to have your proper testers. You have to have your meter, your multimeter tester. You have to have also this kind of tester. It's basically a regular. Basically, what it does is it detects power. Um, Again, I don't use this in real life situations. I go to my meter is, and I'm sorry, I don't have my meter right here. I will show you on the next live stream. This is just a regular. I wouldn't depend on this to actually save my life. This is just to test to see if you do have power there, but to actually know and find out how much power you actually have there, you want to put your actual meter on the tester itself to see what it's reading, to see if you have an open or a ground fault, your so and so on. Again, that's the multimeter tester that I would use. I wouldn't use this two actual test circuits. And again, also having the breaker finder tester is also great too for troubleshooting. Saves time. So when it comes to troubleshooting, always best to have the proper tools for the job. Um, so panel mapping, again, when it comes to panel mapping, you want to make sure that you have it done correctly. Again, service calls is another one where you're going to have a lot of troubleshooting. So for those who are tuned in to the live stream, don't forget you can join the channel also. And I'm going to go back over and show you guys the actual video if you missed the live stream at the beginning of the live stream. I'm going to show the actual breaker in use. So let's go here. This is going to be about 4 short videos here. I'm going to show the...
Stop guessing breakers like this. Electricians use a breaker finder instead.
So that's
Scan the
key
panel.
tester.
Correct breaker lights up.
Working. That's
and it finds the correct breaker instantly.
Red light coming
KAIWEETS
on.
sent me this
You can
breaker
see the,
finder to
voltage
test.
reading on it. You can see it blinking. That blinking that you just saw, what that is basically telling you that the circuit is off. So the blinking that you just saw on the video, that is telling you that the circuit is off. I'm going to run another 18-second video again here.
Ever spent 10 minutes trying to find the right breaker? Electricians use a breaker finder like this. Scan the panel and it finds the circuit in seconds. KAIWEETS sent me this breaker finder to test.
So what that was is basically the scanner in action. The scanner in action, and the scanner is basically showing you that it's red. When it's red, it's basically telling you that you have the proper circuit. You found the proper circuit. I'm going to run another video here, really short videos. Again, this is engagement questions for all those who are tuned in to the live stream. Simply don't forget to like up the live stream as you guys enter. Please and thank you. Very important for the live stream.
Most electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule. Anything running over 3 hours, that's a continuous load. If you don't size this properly, you're setting yourself up for failure.
Saw there was the actual, I'm going to show you guys here. What I did on that job there was I removed the actual wires from the Morex. I made the wires live, and I used the actual clip-ons here. The leads, I used my leads, and I ended up plugging it into here. And by me doing that, I was able to turn on the circuit, and that I'm going to show you this last video here I just run. Very important. You're going to see an orange sign, an orange light on the scanner itself. Pay attention to
Most
it.
electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule. Anything running over 3 hours, that's a continuous load. If you don't size this properly, you're setting yourself up for failure.
So again, what that was, the orange light was basically telling you that it's an open ground. You saw the screen. The screen was lit up orange, basically. So after I was able to remove the actual device from the wires, turn the circuit off, put my leads on, turn the circuit back on, and it pretty much lit up red, orange on the screen. That's an open ground. So again, the beauty of the tester is digital, and it tells you everything on it. So that is the third video. I'm going to show the last video of the shorts um, that I recently dropped on the channel of the breaker finder. So this is the last video here. So again, for all those who are tuning in, this is Q&A engagement questions. You can basically drop a comment in the comment section. I'm answering live, or if you feel you want me to drop the link, I can drop the link also in the comment section. So again, this is a live stream tonight, brought to you by Fabian Electrical Services Inc. I'm Fabian. This is the last short I'm going to show here. So
Stop guessing breakers. Most electricians are flipping breakers. Instead, use a breaker finder. Scan the panel. Find the breaker in seconds. This saves time on every job.
So again, what that was me troubleshooting in real life people. That was me troubleshooting in real life, and not walking back and forth to actually find the circuit. Again, when you have to troubleshoot, you're going to mostly have to troubleshoot when the breaker when the panel is not labeled correctly, when your circuit is not sized accordingly, 80% rule, when you're not using the proper breaker to the proper size wire, 20 amp 20 amp breaker, you have a 12 2 wire that's going to feed into the breaker. The breaker is going to protect that wire. Again, the breaker is there to protect the wire, protect the circuit, and not the device, as all of us get it wrong a lot of times. Again, you're going to see I have a pin comment. Again, stop guessing breakers. The tool I use is KAIWEETS KT301P. The link is pinned at the top of the comment section for all those who are interested in the tool. Is pinned. You can click the link and head over to the actual website also. And I also believe there is a Amazon link, but it's not in there right now. You can find it on the last short that I dropped. I'm actually going to pin it in the comment section after the live stream. So again, tuned in for that. So troubleshooting is important. We should all be able to troubleshoot. Again, to troubleshoot, there's one thing to troubleshoot, but there's another thing to know what you're doing, and also having the proper material to get the job done. So again, for those who are tuned in, this is a engagement question. Again, would you use something like this, or still flip breakers constantly and waste time on the job? You know, time is precious to us, so the more time we waste, the worse it becomes. So using tools, breaker finder tools, is very vital to the job. Um, Again, I remember a lot of times troubleshooting and walking back and forth to the actual panel. Again, it is kind of annoying to walk back and forth. Um, but again, you have to find the proper tools that's going to fit your needs, and also that's going to get the job done correctly. So again, this is especially useful when nothing is labeled. That's what you also can use it for. And I am going to run the live stream for another 10 more minutes before I actually log off to the live stream. So again, this is engagement question. You can drop your comments in the comment section, and I will try to answer you guys live tonight. Also, again, don't forget, you can join the channel also. So again, let's see what's going on here, guys. So let's see here. Tonight's live stream here. I am going to head back over to. Actually, I'm not going to do the video here tonight, guys. The big video. So again, I dropped a full video showing this tool in real life conditions. Go check that out after the stream. Also, make sure you subscribe. I break down real electrical work, not just theory. For those who are tuned in to the live stream tonight, this is live Q&A. You can drop your comment in the comment section. And tonight's live stream, again, electricians get this wrong. Breaker sizing explained, OESC 2024. And in tonight's live stream, you would have seen me demonstrating how I go about finding my circuit using the breaker finder, and also how I go about using the code book to size my my wire and my circuit to the actual code book. Also using the continuous load, the 80% rule. Again, code rules I would have covered. Rule 8-104. Again, it's an 80% rule. Again, continuous loads must be calculated at 125%. Example, if you have a 20 amp breaker, you times it by 80%, you get 16 amps continuous load. Electric heater drawing 16 amps. A 20 amp breaker can safely carry about 16 amps continuously, guys. Don't forget that. Very important. And also when it comes to the EV charger circuit, electric heaters, I'm not going to, that was covered in my last live stream. So you can visit the last live stream that I did run last week. And you can replay the live stream and you will find that info there. Again, for those who are tuned in, I go live every Wednesday at 9 p.m. I also drop my videos on Mondays in the evening around 6. So you can look out for my videos, my long form videos on Mondays. And the shorts, I also drop them during the week also. So if you haven't subscribed to the channel, subscribe to the channel and stay up to date to the actual content. Again, tonight's live stream, why electricians get this wrong. So again, for all those who are tuning in, this is a live Q&A, and I don't want to play the full video. There is a video that I have where I was going to explain about troubleshooting here and the proper tools for the job, but I'm not going to play that video. That video is going to be too long here. Again, if you guys are tuned in, again, sorry about that. I had to go and get my tooth clean. I guess I don't have rotten teeth again. So again, thank you guys all for tuning in to the live stream tonight. Again, you are tuned into Fabian Electrical Services Inc. And the live stream was basically about the breaker finder, breaker finders, how I go about using it, and also covering the rules 8-104 of the OESC 2024, and also 14-100, touching on breaker sizing. Very important. Breaker sizing is very important. Make sure you have your circuit size accordingly. Why? When you size your cable accordingly, when you size your circuit accordingly, you don't have any short circuits, you don't have any overloading. The circuit can last for a very long time. Again, it's very important. Don't jam everything on the circuit itself. When you do that and you start to mix and mingle circuits, what happens is you have so many different things drawing so many different current. It creates dirty power. Dirty power basically happens when you're over your 80% rule. That's when your dirty power kicks in. That's when basically you can have a shot or so on. That's when you have the neutral, unbalanced neutral is called. That's where you have your dirty power coming back. So again, it's very important to keep that in mind. And I am going to, let's see here. So again, for all those who are tuning in to the live stream, if you missed the live stream, I'm going to run one more clip of the live stream if you guys missed it.
Most electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule. Anything running over 3 hours, that's a continuous load. If you don't size this properly, you're setting yourself up for failure.
Okay, so that was the short video there. Again, for those who are tuning in, if you're tuned into the live stream right now, don't forget to like up the live stream. Also, I'm going to be ending the live stream right now. So I'm going to give it 5 more minutes, guys, and I will see if someone is going to comment, leave a comment, or okay, you know what? I will run one video here for you guys. So basically, what that is me using the old circuit breaker finder. As you can see, I'm walking back and forth to troubleshoot. As you can see, it's a far distance. I have to walk back and forth in order to find the circuits. Again, with the KAIWEETS circuit breaker finder, I can stay at the panel. I can plug in my actual transmitter in here, leave it in here, make sure my Wi-Fi signal is picking up, go to the panel and scan. So this is what I mean by saving time. Look how many times I have to walk back and forth here in order to find the actual circuit. So this is one time here. I don't remember how many times I did actually walk back. This video just happened to be here, so I'm going to play. So again, see, I'm walking back again to the actual circuit itself to try to troubleshoot. And this is basically what I mean by walking back and forth. This is at least 5 minutes I could have probably saved with one shot. Plug in, go to the panel, scan, I'm done. I found my circuit. I move on to the next circuit. But this is again the old tester that I have, that I am working off of. Again, it does beep, but by the time I hear the actual beeping, which is way on the other side, it's going to actually take some time to actually hear it. So this is just, again, me walking back and forth, troubleshooting, trying to find the circuit with a breaker tester, actual plug-in tester, it's called. Um, this is the, as you can see, the green light is on. The green light tells you that you're basically, the circuit is correct. That is the circuit. So that's how I used to go about troubleshooting. Now I've switched it up now, and I've gone to the actual tool itself where I can stay. So here's another video here. I have it plugged in, and I'm going to be walking back and forth to find the actual circuit. Um, Right, Kim, thank you for joining the live stream tonight. Thank you for checking into the live stream. So again, I'm going to, let's see here, guys. So tonight's live stream is brought to you by Fabian. I'm Fabian Electrical Services Inc. I'm Fabian, and again, I'd like to thank everyone for tuning in to the live stream. Goon Platoon and Kim. So again, that is the actual. If you see how many times I've walked back and forth to actually find the actual circuit, it is annoying to actually walk back and forth. So again, that is basically what I used to use, guys. It's a plugin tester. So if you missed the live stream tonight and you want to check out the replay, you can head over to the and if you missed the replay, you can catch it on the replay. If you missed the beginning of the live stream, sorry, you can catch it on the replay. So again, that is me troubleshooting, guys, using the actual plugin tester. That's how I go about troubleshooting, guys. So that is the old way that I used to go about troubleshooting, guys. That is the old way. Now I basically use the new way, which is walking back to the actual having my tester, my KAIWEETS brand tester is basically what I use to troubleshoot, guys. So again, if you missed the beginning of the live stream, you can check it out. You can check it out on the replay. You can also, at the end of the live stream, I did drop the full video of the breaker finder. I did drop the full video on Monday. You can check out the video if you want after the live stream. So um, that was the last video I just played there, guys. For those who tuned in, you are tuned into Fabian Electrical Services Inc. I'm Fabian, and again, if you do want to drop your comment in the comment section, you can drop a comment in the comment section. This is the engagement question section. I'm going to let the live stream run for another 5 minutes. I will play a couple more videos for all those who missed the beginning of the live stream. It is going to be just the short 20-second videos here.
Most electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule. Anything running over 3 hours, that's a continuous load. If you don't size this properly,
So
you're
this is what I
setting
mean
yourself
by
up
using
for
the
failure.
proper plug-in tester, breaker finder tester. Again, it is a plug-in breaker finder tester. Gets the job done fast. You saw how I was just walking back and forth. It was basically a pain to do the job. It took me a very long time to actually try to find those circuits. But however, I've moved away from that, and I'm going to be troubleshooting a lot smarter. And instead of wasting time, I will be using the proper plug-in tester, breaker finder tester, that's going to get the job done accordingly. And this is basically the one that I'm talking about here. So I'm going to pull it up on the screen for all those who
Ever spent 10 minutes trying to find the right breaker? Electricians use a breaker finder like this. Scan the panel and it finds the circuit in seconds. KAIWEETS sent me this breaker finder to test.
so So let me show you guys another video here, another 26-second video here.
Stop guessing breakers. Most electricians are flipping breakers. Instead, use a breaker finder. Scan the panel. Find the breaker in seconds. This saves time on every job.
So again, that is the that's what I go about doing troubleshooting. Again, very important to troubleshoot. You guys try not to overdo it when it comes to troubleshooting. Okay, so Let's see here. So again, I don't want to play big videos here. So I'm going to, oh, okay. That's what I'm going to do. So again, a lot of us tend to undersize our cables. And again, if you see here, what I have here is two sets of breakers. One is a 20 amp 2-pole. The other one is a regular 15 amp breaker. This one is your 15 amp. This one is your 20 amp 2-pole breaker. Again, what these breakers do is sizing your cable accordingly. You cannot use a 14 2 wire on this breaker here. You can only use it on this breaker. Why? Because the breaker does not allow it to work that way. It does not allow. It does not protect the wire itself. So it's very important. You have to make sure that you protect the wire itself. So using the proper size wire for this will be a 12-2 wire and not a 14 gauge wire. Again, this is where you would use your 14 2 wire on this 15 amp circuit, which will give you basically 15 amp breaker, 15 amp in power. And this is basically the 20 amp. This is a 20 amp 2-pole. You will use this on the 2 hots. Let's say you have a split receptacle in the kitchen. A lot of times it will be a 15 amp split. This is a 20 amp. This is best used for air conditioners and so on, heaters and so on, higher voltage to actually make the circuit work accordingly. So this is what this is, and that is going to be my wrap up for the live stream for tonight. Okay. Okay. It's 11. You know what? Let's run. I will run a couple videos here before I log off the live stream. It's been a while, so I'm going to run a couple videos before I actually log off the live stream here. I'm going to make it align with the tonight's topic. So let's go with the actual installation of the
Hello, welcome back to my YouTube channel. I'd like to thank you guys all for tuning in to today's video. As you come in, please don't forget to like up the video, very important. Also, you can share the video. You can also subscribe to the channel, and you can also become a member of the channel with the link being pinned in the comment section. Again, what I'm simply doing is preparing to remove this panel for a panel swap out, 100 amp to 100 amp.
So again, welcome back, you guys, to the channel. Thank you guys
and the
all
reason
for
why I'm
tuning in
changing
to
this
tonight's
panel
live
is
stream.
because it's defective in the
And I'm going to
area where
run
I am, the country
maybe
where I
one
am.
or
It's a
two
fire
videos,
hazard,
and then I'm going
and also there's not
to
enough
actually log off
space in
the
the
live stream.
panel to do what I need to do with all of the new circuits that I've brought in. So again, that's what I'm going to be doing right now. It's a panel swap out with the power being turned off from the hydro unit. So just stay tuned for the entire video, and I'll catch you guys in between the video. So again, hello and welcome back to the channel. So normally what I do when I'm doing a job like this is I normally get to the job site a little bit earlier so I can remove all of my wires, label them accordingly. That way when it comes to reinstalling my wires into the panel, I don't have to go troubleshooting throughout the house for the circuits to be labeled. And yes, of course, your cables and your circuits have to be labeled at the end of the job in order to have your inspection pass. That is the code rule, and there's no going around it. So again, just stay tuned for the entire video as I attempt to change out this panel without any issues occurring, any
Sorry
delays.
about that. So again, this is a job that I'm working on, and it goes back to the actual breaker topic.
Limited time that I have during the day. If I don't have this panel,
The importance of labeling the circuits once you're about to close off your inspection job, very important. Always make sure to label your wires before you actually change out your panel. Saves you on troubleshooting, saves you on pulling out the actual circuit breaker finder.
I have limited space to work with.
So you don't just swap out your panel and forget about labeling the wires before you actually take the panel off.
So
you actually remove your wires from the breakers and try to label your wires before you remove them from the panel.
Of this area,
and once everything's labeled, then you can remove your cable from the panel and you're good to go. It's going to save you a lot of time at the end of the job. Or you're going to use a breaker finder tester, which is also very important to have when it comes to troubleshooting. If you don't have, you can't find the circuit, because let's face it, a lot of older homes, the circuits are not labeled accordingly, and when we do go to actually change out the panel itself, we actually have to relabel everything inside of the panel. So that's where the breaker finder comes in handy. It's best for troubleshooting, renovation, panel upgrades, service calls,
just keep in mind that
and so on.
With limited time, there's very few mistakes that can be made. Even being, like I said, it's a panel swap out.
So again, I'm going to give you guys two videos. Again, this is an engagement question. So if you guys are there and you want to drop a comment, you can. Otherwise, I will run this one video here along with another video, and then I'm going to be actually logging off the live stream. So this video here has about 4 minutes left of it.
Screws and stuff like that on the other side of it. Very hard to play with. So for that reason, I have to take my time also to make sure that I do not make very important.
Okay. So
my wires are nicked and it touches the metal. Once I reinstall my wires, then it can have a sharp in it of some sort. So always try to avoid all of these little stuff that comes with the trade. So again, just sit back and enjoy the rest of the video, and I'll catch you guys in between video. Please like, share, and subscribe to my videos, and leave a comment in the comment section. Thank you. So hello, welcome back to my channel, and what we simply have right here right now is going to be the installation of my cables and so on. This is a 400 main disconnect fusible parallel feed being used.
I'm going to run one more short video here, you guys.
So hello again and welcome back to the channel. And again, reason why I'm installing this tape is because I have to identify Fabian Electrical Services Inc. Subscribe today for more worldwide electrical tutorial. Stay up to date with the code content. Leave a like on the video. Subscribe to the channel. Share the video, and also you can.
I don't want to play that video there. Okay, so that's going to be a wrap up for tonight's live stream. Again, I would like to thank you guys all for tuning in to tonight's live stream. Topic: Electricians get this wrong. Breaker sizing explained, OESC 2024. Again, for all those who tuned in to the live stream, thank you guys for tuning in. Also, like to thank Gun Platoon for tuning in to the live stream, and Kim Wife for Life for tuning in to tonight live stream. Again, also for the video, I dropped full video showing this tool in real job conditions. Go check that out after this stream. Make sure you subscribe. I break down real electrical work, not just theory. As you would have seen the demos, the KAIWEETS circuit breaker was introduced to the live stream tonight. So that's what I basically use on the job site. And again, I would like to thank you guys all for tuning in to the live stream. And I will catch you guys next Wednesday at 9 p.m. same time.